Fine. So in today's object-oriented system design lecture series, we are going to start up with the next topic, that is arrays, right? Arrays and pointers. So the basic fundamental of array and pointers are same as we have already studied in C, right? C language. Now it has these certain concepts which are different in C++. Those are just like talking about the syntax, but the concept is same, right? So let's start with the array. Now, basically, what is an array? Till now, we have studied that whatever we are storing, whatever we are giving in a program is data, right? And that particular data has to be stored in a variable. So we have studied the variables, right? We have variable in which we are storing that particular data in that particular memory location. Now, in variable we are going to store only a single data, right? But what when we want to store a series of data, when we want to store a large number of data, right? At that particular moment we are going to use what? We are going to use the array. So array is just a expanded version for variable, because variable is being used to store a single data, while when we have to store a series of data we can use the array, right? So array can be defined as a collection of elements of similar data type. This you have to remember, that whenever we are going to define the array, when we are going to declare the array, we are going to store the same type of data in the array. That particular cannot be of different, right? So it's like if I'm going to initialize the integer array, so I'm going to store all the values which are integer values. I cannot store one integer, one double, one char. Okay, so that should be all integer values. So same type of data is being stored, right? And that is being stored in a contiguous memory location. Now, what is this contiguous memory location? It says that when I'm going to define the array, the data type, the data I'm going to give, that has to be stored in a contiguous memory location. That means it is not going to be stored randomly anywhere. It has to be in continuation. So if something is stored at this particular place, that is 0, the other will be stored at 1, next one will be stored at 2, next one will be stored at 3, and so on and so forth. So that will be in a sequence and a contiguous memory locations. These are the memory locations example. Now every element in an array has a specific index. Okay, now next thing what we have to define, we always have to define the size of the array. Very important part, size of the array has to be defined in C++. That means whenever we are declaring, whenever we are defining the array, we have to define the size of the array. That means how much data we need to store in that particular array. Okay, now arrays are of two types basically. They are being single dimensional and multidimensional. What is this single dimensional and multi-dimensional? You all know single dimensional means when we have just one row with number of columns, that has to be defined as single dimensional. And when we define multi-dimensional, that means it is a kind of a matrix form. That means it has number of rows and number of columns. So how do we define this? It can be defined as 0, 1, 2, 3, right? So it has how many? What is the size of the array in this? The size is 4, right? The size is 4. Why 4? Because we are starting from 0. So the size of this particular single dimensional array is 4. Now, when we talk about multidimensional, how do we define? We define this particular location we have, see, we have this is 1 and this is 2. We have 2 rows, okay? And how many columns we have? We have 1, 2, and 3. We have 3 columns. We have 2 rows and 3 columns. So how do we define the size of this? As 2 into 3, same as we define the matrix. How do we define the location of this? It's like 0, 0. Okay, 0, 1. This is 0, 2. Now what is this? This is 1, 0. This is So this is defined as 0 0 means 0th row and 0th column. This is 0th row and first column. This is 0th row and second column. So from 0 1 2 we have three columns out here, and this is 0th row and this is 1th row. So 1th row and 0th column. This is 1th row and 1th column. So this is 1 1, and this is 1th row and second column. So this is 1 2. Okay, so this is how we define the multidimensional array. Now let's understand how do we define and how do we give the definition and the syntax for this particular array. Okay, because this is very important when we prepare the programs, when we design the programs. What we need to define, we need to take care of the syntax with the logic, right? So how does this particular definition or an array can be defined in C++ is, first of all, you have to give the data type. We all know what is data type. We have already studied. Let's say we have integer, long, we have char. So these are what? These are the data types. Next one, we are going to give the name of the array. Okay, we can give any name to the array. We can give, let's say, A, we can give I, anything, right? Next, we define the size of the array. As I told you, whenever we are going to define the array, it is very important to define the size of the array, right? So the size of an array must be an integer. As I have told you that here, what is the size of the array? The size of the array is 4. Okay, so and here the size of the array is, when we define it multidimensional, 2 into 3. This is the size of the array. Okay, so that has to be defined in the place where we are defining size of the array. So how do we define it? Example, let's say, how do we define it? We say data type, let it be int. Oh, okay, we have already defined here in the syntax. This is what? This is the data type. What is this? This is the name of the array, A. And what is this? This is the size of the array. The size of the array has to be defined in the square brackets. Okay, so this is the definition, or this is the syntax for single dimensional array. When we define the multi-dimensional or double dimensional array, how do we define? We define it as, let's say the data type is double. This is the name of the array, that is B, and this is telling you the row and the column. The size of the row, that is 10, and size of the column as 10. In the earlier, if I take the example, so how do I define? I define it as, in this particular brackets 2, and in this particular bracket I'll define it as 3. Okay, so that will be the multidimensional array. Now next thing comes, how do we initialize the array? See, we have two types of initialization. In anything, let it be a variable, let it be array, we have two types of initialization, that is called as, one as the static initialization and the other one is called as the dynamic initialization. What is this static initialization? Static initialization is when we are hard coding the code in the program. That means when we are defining the values in the program itself. Let's say I have defined the array and I have initialized this array, right? I have taken integer as the data type, A is the name of the array, and 10 is the size of the array. So it will be what initialization is. We have defined it 0, 1, 2, 3, 4, 5, 6. Sorry, 10 will not be here. Okay, because this is 10. So 0 to 9 it will take. Okay, so 0 to 9 is what? This is the values which are being stored. So it is a way where we are hard coding, where we are already defining the values in the array. Similarly, char C5. So char is what? Data type. C is the name of the array and 5 is the size of this particular array. So we have defined, because this is char, so I have to define it in inverted quotes, H, E, L, L, O. So this is what? This is the static initialization, where the data values cannot be changed. But the other point is, other way is called as the dynamic initialization. What is this dynamic initialization is? See here, what we are saying, we are just declaring the array, but the values can be entered by the user also, right? User can give different values and that can be initialized in the program. So there we are not hard coding the values, right? In static we were hard coding. In dynamic we are not hard coding, we are taking the input from the user. So that is the difference between the hard coding and the static and dynamic. Here this is the data type int, this is the name of the array a, and this is the size of the array, that is 10. Now here what we are doing, we are just starting up the loop. We are taking the for loop. Why we are taking this for loop? We are initializing it and we are incrementing till we get the value as 10. Okay, what is n here? As 10. So I is equal to 0. That is, from here it is going to start the value of I. I is equal to 0. I have to increment this I till I get I, until the I value is less than n. As soon as it is equal, the for loop will stop. And here I am taking the input as C in greater than sign AI. That means the console will print the values, will take the user input from this, right? Let's see how the program goes. I've taken a demo program out here in which I am starting up with the, now here we can see the program. We all know what is using namespace std. We have hash include iostream. We all know why you are using. We are using this because we are using cin and cin out. Now int main starts, and here we have declaring the array, right? We are doing both the things. We are initializing the array and we are declaring the array out here. Now what we are doing here is int, that is the data type of array, that is integer. A is the name of the array, and here we declare the size of the array, that is 5, and we are initializing it. We are defining the data also, that is 1 2 3 4 5. This has been defined here, right? We will put a semicolon. Now if I want to print this, if I want to print these values, how will I do it? I'll take for loop integer I is equal to 0, I is less than 5, I plus plus, that means it starts from 0, increments again and again till the value is less than 5. As soon as it is equal to 5, it will come out of the loop. And till then what will it do? It will print the value. Cout is used for printing, okay, displaying the values. So AI will be printed. So what will be printed? The output will be 1, 2, 3, 4 and 5. Fine. So these are the values which are given. Now if I include slash n, so that will be, the values will be printed out in what? In next line. Okay, that you all know. Now moving further, we have, that was for integer value. As hard coded, we have hard coded the integer value. That means this is what? This is the static initialization. This was the example for static initialization. Okay. Now we are talking about the character values for static initialization again, because this is hard coded. Here we have the same thing is to be done, only the initialization, only the declaring of array is different. Why? Because we have defined the different data type, that is char. C5 is equal to, in curly braces, H inverted quotes, comma E inverted quotes, L inverted quotes, L inverted quotes, comma O inverted quotes. Okay, then same for loop will be done, and same thing is done here. Now what is this I have provided? I have provided a space here. If I put a slash n, okay, then what will it do? It will give it the displaying in the next line. So what will be the output for this? It will be H space E space L space L space O. So this will be printed out. So this is the static initialization again. Now we can see the dynamic initialization. What is this dynamic initialization? Dynamic initialization is when the user needs to input the data. Okay. So we can see here, we can start from here. The array is initialized int a, brackets 5. So integer data type, A is the name of the array and 5 is the size. C out, enter values in the array. It is asking to enter the values in the array. So we have started the for loop. Int I is equal to 0, I is less than 5. Why 5? Because we have taken the array from size as 5 and initialize with 0. So it will be 0 to 4, right? If I started from 1, then it will be equal to 5. Okay. So this we all know. Then I plus plus cin we are going to do. That means we are going to take the values. Okay, we are going to take the values. Next line will be seen, and then we have C out, that is the values entered by you are. Again the for loop will be taken up with the same concept, and it will display with the help of C out the values. How it is going to be? Let's say I can see the portal and I can see enter the values in the array. Okay, enter the values in the array. Let's say I give 10, 20, 30, 40 and 50, because I have to give 5 values. The size is 5. Okay, so 10, 20, 30, 40, 50. It is scanned from here, and when I say C out, it will display it as 10, 20, 30, 40, again 50. Okay, that will be the output for the same. So this is how the program is defined in the array when we are taking the dynamic input. Okay. Now, when we talk about pointers, see, these are the basics. Pointers are used when we define, see, pointers is just like variables, but the only difference is variables are storing the data, while when I talk about pointers, pointers are storing the address of the memory location, address of the variable where that particular has been stored, right? So variables are going to store the data, and pointers are going to store the address of that particular variable where it has been stored in the memory location. So that is why we are using the pointers. Now see, pointers are variables which store the address of a variable. They have, sorry, they have a data type just like variables. For example, an integer type pointer can hold the address of an integer value, and a character type pointer can hold the address of a character variable. That means it is necessary to define the data type for the pointer also, same way as we define the data type for the variables. Whatever value is being stored in the variable, whatever data type is going to be stored in variable, the same data type has to be defined for the pointer for which it is going to fetch the address. Okay, so let's say if a is an integer, right? If a is an integer and I have defined int a is equal to 10. Now in this I have int pointer. This is what? Asterisk p. Now the only difference how the system, how the compiler is going to differentiate between a pointer and a variable is this asterisk sign. This asterisk sign, if this asterisk sign is provided before the variable, then it makes the pointer, else it is just a variable. If before a I make a asterisk sign, then it will make it a pointer, then the compiler will judge it as a pointer, right? And how do we store the address is ampersand a, that is the location of a, the address of variable a. So this is the syntax for using the pointer, initialization of the pointer. We are declaring the pointer out here, right? Now, moving further, if I just define the demo program for the pointer, I define, let's say we have IO stream, we have string taken. These are what? These are the header files, namespace, std, int main here starts. Now see, it is, earlier I took an example of integer value. Here I have a string, right? I'm taking a string, and the name is what? It is the variable. String is the data type. String is the data type and name is the variable in which I have defined what, in which I have stored great learning. So this is what, this is a type of variable which is type of string, and it has the value as great learning. So string asterisk pointer, why asterisk pointer? Because I'm going to get the address of variable name. So string asterisk pointer is equal to ampersand name. That means asterisk defines what? Asterisk pointer is going to tell you that this is a pointer. This is going to differentiate it in this way, and ampersand name is going to define that it is going to take the address of the variable name where it is stored. Now if I do see out name, and then again I do see out ampersand name, what it is going to give? This is see out name, it is just going to give me the value which is stored in name, that is great learning. I'll get the output here as great learning. I'm writing it in short form. I'll get the output as great learning for this. For this see out ampersand name, what will I get? I will get what? I'll get the address of this name. So it can be anything like 0, F, whatever the address is. A, right? So this address will be given where the and is, so where the name is stored. Next one is see out ptr. Now it is going to give you the same thing which is given by this ampersand a, because this is equal. Ptr is going to give you the same value, that is the address of name, and this is again going to give you the same value as address of name. So let's say if it has given you 0 FFA. So it is also going to give you 0 FFA. I'm just taking a random memory location, right? So I'm just going to tell you that how it is going to take. It is going to take as the name is going to give you the variable is, this is variable. So it is going to display the value which is stored in variable. Ampersand name, that is, it is going to give you the address of variable where this is stored, and ptr is again going to give you the address of the variable which is again it is going to store. So this is how the pointer is being used, right? This is the program we have taken up. It is same. We have given it in a more compact form, that is see out value in variable. Then we have given two blank lines, and then we have taken the address of the variable, that is ptr. So I get the value in variable through name, and I get the address of the variable through both the things, that is from ptr also I'm getting the same thing, and from ampersand name also I'm getting the same thing, right? So this is how the pointer works. Now